All right, let's dive in and really crack a full GCSE chemistry question on metals. We're going to walk through the perfect answers step by step, and we're going to use the official mark scheme to see exactly what you need to do to get those top marks. So, here's our game plan. We're going to break down every single part of the question, from identifying properties to planning experiments and even tackling the math. By the end, you'll know exactly what the examiner is looking for.
Okay, so here's the challenge we're tackling. We're zeroing in on question 02 from this AQA paper. It's a classic question, and it covers that core topic of metals and the reactivity series.
You know, the tricky part here isn't just knowing one topic. It's about how you connect all these different key chemical ideas, moving from just remembering facts to actually applying them. So, let's get into it.
Okay, first up, let's tackle a multiple choice question. This one's really about testing your basic, foundational knowledge of transition metals.
So the question's pretty straightforward, right? Pick two properties of most transition metals. This is a total classic, a 2-mark recall question just to check you've got the basics down. So, what are the right two?
And here they are, the two perfect answers. Transition metals form ions with different charges, like iron 2 and iron 3, and of course they have super high melting points. They're definitely not low density, they're typically pretty heavy, and they're famous for their colored compounds, not colorless ones. So yep, those two are your ticket to the full marks.
All right, so we're moving on from simple properties to actually interpreting what's happening in a reaction. This next bit is all about connecting what you see with the chemistry behind it, specifically reactivity.
Okay, now this is a 3-mark question, and that right there is a huge clue. The examiner isn't just after a one-word answer. Nope, they want a clear, 3-step explanation that links your observations to the whole idea of reactivity.
So the trick is to break it down into 3 simple points. Point 1, those gray crystals you see, that's solid silver. Point 2, why is the solution turning blue? Because copper ions are forming. And for the final point, you just tie it all together. This happens because copper is more reactive, so it literally pushes out, or displaces, the silver from the solution. Boom, that's your 3 marks, right there.
And check this out, here's a really useful detail straight from the mark scheme. For that second point, you don't have to just say copper ions. You can actually get the mark by being more specific and saying the copper nitrate compound is what's making it blue. It just shows you've got that slightly deeper level of understanding, and it's another perfectly valid way to score.
Okay, get ready for the biggest challenge in this question. A 4-marker that asks you to plan a whole investigation from scratch. This is where you really get to prove you understand practical science. And pay close attention to this key phrase. Your plan should give valid results. That's basically the exam's code for describe a fair test. The whole goal here is to come up with a method to tell these 3 metals apart just by how they react with acid.
So, if you want top marks, the mark scheme is looking for a really clear logical plan. First, you add the metals to the acid. Simple enough, but then, and this is key, you've got to measure something, either the temperature change or how fast it's bubbling. From there, it's a process of elimination. Copper, it won't react at all. And then you can tell magnesium and iron apart because magnesium will go absolutely crazy compared to the iron, bubbling way faster or making the acid much hotter.
Now this part is the secret sauce for getting those valid results marks. It's all about controlling your variables. To make sure it's a fair fight between the metals, you have to use the exact same concentration and volume of acid, the same mass of each metal, and even the same particle size. Listing these control variables is just as critical as describing the steps themselves.
All right, let's switch gears a bit. We're moving away from the lab bench and over to the calculator. This final part of question 02 is a test of your math skills and whether you can handle a classic chemical calculation.
So here's the data they give you. You've got this unknown metal, M, and it has 2 isotopes. Remember, that just means atoms of the same element but with a different number of neutrons. One isotope has a mass of 203, and it's 30% of the sample. The other has a mass of 205 and makes up the remaining 70%. Your job is to figure out the relative atomic mass.
Now, to get every single mark here, you absolutely must show you're working. The method itself is pretty simple. You just multiply each isotope's mass number by its percentage, add those 2 results together, and then divide the whole lot by 100 to get that weighted average.
And when you run those numbers, it brings you to the final perfect answer, 204.4. And don't forget that little instruction in the question. It says, give your answer to 1 decimal place. That final check can be the difference between a right and wrong answer.
Okay, so we've pulled apart every single bit of that question. Let's just zoom out for a moment and think, what skills was this one question actually testing?
And honestly, this is why it's such a fantastic question to really get your head around. In just 4 little parts, it manages to test you on 4 totally different but super important areas of chemistry. It's checking your memory, your ability to explain ideas, your skills in planning an experiment, and of course, your math.
So what's the big takeaway here? Well, it's this. Those principles of a fair test, controlling things like concentration, volume, and mass, they're not just for this one question. Think about it. How can you apply that exact same logic to every single practical you ever do? Because mastering that skill, well, that's the key to unlocking marks across all of your sciences.